When creating a full-text index, there's 4 options to keep in mind: the storage location of the index, the accent sensitivity of the index, if change tracking is going to be used, and the population schedule. The storage location is the file group within the SQL Server database engine that the full-text index will be stored within. Accent sensitivity tells the SQL Server if we're going to look for accents within the words that we're searching for, and if we're going to follow those accents, or if we're going to simply ignore accents. If change tracking is turned on, then the full-text index is updated automatically as new records come into the table or as records are modified. If change tracking is not turned on, then we need to populate the full-text index based on a schedule. The upside to populating the full-text index on a schedule is that performance is not impacted for insert and update operations. The downside is that new records and changes to records will not be included within the index until the population schedule has triggered a new population. Let's go ahead and look at a demo and look at how to create a full-text index. As you can see, we have the AdventureWorks 2012 database loaded up on our SQL Server instance. We'll expand storage and then full-text catalogs and see that there's already a sample full-text catalog in there. We're going to create a new full-text catalog as part of this demonstration. To do so, right-click on Full-Text Catalogs and select New Full-Text Catalog. We then give the full-text catalog a name, and we specify an owner. In this case, we'll specify the owner as DBO. We click OK, and the catalog is created. We can now open the catalog and view several properties about the catalog, including the size of the catalog and how many items there are within the catalog. We also can see the accent sensitivity, which we can turn on and off if we need to. We can then select the tables that we wish to create the full-text index on. In this case, we're going to find the person.person table. And we're going to click on the arrow to move that into the index. We then select the unique index we wish to use as reference within the index. Normally, you're going to want to use whatever unique index is the primary key. If there are other unique indexes available for the table, they'll be shown here. Whichever unique index you select here, the columns that make up that index will be the columns that you have to reference when using the full-text join predicates to query the full-text index. So in this case, we're going to select the primary key. We can then select the columns that we wish to include within our index. We're going to select all 3 of the name columns. Various other columns listed here, but realistically, searching on those columns probably would not be useful. We're going to set our change tracking schedule to automatic so that we don't have to worry about scheduling populations to happen. If we wish to schedule populations, we can set a population schedule here by simply clicking New and giving the job a schedule. This is the standard new job schedule window that you see throughout various presentations and within SQL Server Management Studio. Once we've made the necessary changes and selected any tables we wish to have, and we could select multiple tables in here should we desire to, we can then click OK. That will create the full-text index and begin the population process. Unlike creating normal indexes, full-text indexes are created in the background, and you do not have to wait for them to complete. This can give inconsistent results when the full-text index is queried while the population is happening. If you had a very large table with millions or hundreds of millions of rows, and you created a full-text index and then began querying the full-text index right away, you would only get partial results back because the background process which populates the full-text index would not have completed the background processing. Whenever possible, use a table which has a big int, or small int data type for the primary key. Looking at the person.person table, we can see that the business entity ID column, which is our primary key, is an integer data type. The use of integer data types, or whole numbers, or real numbers, depending on how you want to refer to them, will improve the performance of the full-text index and make joining of the values between the full-text output and the base table much easier. So in summary, always remember the population is going to happen in the background. So even though you're going to get a confirmation back right away by the command window disappearing that the full-text index has been created successfully, it has not been fully populated yet, even though it has been created. Always use those numeric data types like int or big int for best performance when creating full-text indexes on tables. This may require a table redesign, but it may be worth it depending on the performance benefit that you see in your particular environment.